Hey everybody, welcome back. This is going to be part two of the video that I previously did on an overview of layers of a communications model and the way that encapsulation takes place and the OSI model and the TCP IP model. Okay, so we are going to focus a little bit more in this second part of this explanation on endpoints and servers and also on layers of the communications model. All right, so I want to go back to where we were talking about the endpoints, a couple computers in a network. You know what, we can just focus on one for now, really. We don't need to keep talking about two. So this computer is initiating communications. Well, yeah, I'll go ahead and draw the other one. It's initiating communications with another computer over there. And so back to the idea of this protocol stack that resides inside of this computer, we have those 7 layers. And I just want to get a little more specific about these layers. All right. So as a network specialist and understanding the functions in networks, you normally don't focus very much on these top 3 layers. You will need to know some of the general ideas or the capabilities of those layers. Particularly for the CCNA exam, you'll want to be able to describe some of the things that take place at the application, presentation, and session layers. But I'll just say that, you know, in your day-to-day job and most of your dealings with networks, you'll be more concerned with these bottom 4 layers. All right? So we're going to spend more time focusing on those layers. So in the process of the app on this computer sending data, you know, over to this computer over here, it began to prepare that data to go across the network. It begins to descend the protocol stack and thus becoming encapsulated as it goes down that protocol stack. When it gets to layer 4, the application will be written to take a path through transmission control protocol or user datagram protocol. TCP is connection oriented, UDP is connectionless. What that means is the application is written to use one or the other. If this is Firefox and we're going to a web server over here, a www service running the hypertext transfer protocol, HTTP, excuse me, I'm scribbling a little bit. Hopefully that's legible. HTTP, then let me write that one more time. So we're using the World Wide Web Service, HTTP. And so this is definitely a TCP-based service, okay? So we can erase UDP there. That application will definitely be taking the TCP path. What that means is there's a logical connection that's established between the TCP layers of these 2 endpoints. I don't care if it's across the world on the other side of the planet. The TCP layer inside of this computer and the destination web server will have what's known as a socket established between those 2. A socket is made up of the IP address over here, colon, the port number that it originates from, and we'll talk a little more about that later, and the destination IP address over here, colon, the port number that it's destined to. Okay? We'll get more into details of various ports and things like that later, but for now, just need to understand that this is true about the TCP layer. It's end-to-end. It's an end-to-end socket, and so this is a stateful connection that's maintained from one computer to another. I would like you to see this on my monitor over here. You can see this table with netstat-an on Windows, and it spits out this table. Look at TCP on the left side or UDP with the IP addresses, whether they're IPv4 or v6, and the colon delineating between the source the source IP address and the source port. Okay, and so here's an example of a port 443, otherwise known as Hypertext Transfer Protocol Secure, HTTPS, where between my workstation and my source port, which is known as an ephemeral port, those numbers would be from 1024 to 65,535, going to destination port 443. This is out of the well-known port space, which ranges from 1 to 24. Excuse me, 1 to 10,023. And so this is the state of the session. Here's another state of another session. Each one of these represents sockets of my IP and destination IP addresses on my network, on wherever in the world these IP addresses reside. This is a connection table in my computer. All right? This is true about Windows, Linux, Mac, whatever device, smart device you're using. This is a state table, and you can probably look at it in any. Now, you have to have access to the command line. You have to have some kind of utility. Some devices aren't going to allow you to see this, but here's how you see it in Windows. Netstat, and I'm pretty sure that's how it is in Nix as well, Linux or Unix. Here's another way of looking at it. You can put this switch here to look at numbers only. You can refresh the table on second intervals, and you can, this is just a trick for limiting your search on the command line in Windows, but check this out. You can see it in real time. I'm listening on a port 139. This is a well-known Microsoft port. By the way, when you click in your command line window, it freezes the output. If you hit the space bar, it begins displaying it again. That's just something you need to know about Microsoft Windows command line interface. So this port 139 is an example of a port that I'm listening on. And by the way, it's a well-known Microsoft port. It's spoken of here. I did a little search for it. 139. It's a NetBIOS session service, TCP port 139. It's a Microsoft.com. You can find it in various places on the internet. It speaks about it. And so I just wanted you to see this is the connection table, okay? So let's get back to the whiteboard. And I mentioned that the source port is usually out of the ephemeral space of 1024 to 65,535. And the destination port of well-known services, for example, HTTP equals port 80. That would be the port over here. And of course, the IP address is the IP address of this computer, and we'll talk more about IP addresses later. And the IP address here is the IP address of this computer. All right? So that's what's taking place at layer 4. So before we move on to layer 3, I want to say one more thing. As your data from your application descends the protocol stack, it is starting to get encapsulated. When it gets to goes down the protocol stack and it gets to a function of layer 4, that protocol data unit becomes known as a segment. So you can generically speak of the user data and its encapsulation just generically I use the terminology, I've heard the industry use this over the years, PDU, Protocol Data Unit. Whatever layer of the protocol model that data unit resides at, you can say, okay, it's a layer 4 PDU or a layer 3 PDU. You're qualifying what layer it's at, and it's just the data unit you're speaking of. But at that layer, there are specific names for those PDUs. So if you say segment, you're actually talking about the protocol data unit as it exists at layer 4. Now let's move on. I'll speak to those, and then I'll put them on the whiteboard so you can have a visual of them. As that gets encapsulated and descends the protocol stack to layer 3, that layer 3 PDU becomes known as a packet. More specifically, an IP packet, an Internet Protocol packet. Okay? As it gets encapsulated into layer 2, if it goes over an Ethernet network, which is predominantly the technology that you find in use pretty much everywhere these days, on LANs, on WANs, in MANs, metropolitan area networks. We'll talk about local area networks, wide area networks, metropolitan area networks, carrier Ethernet, and just metro Ethernet, just wherever Ethernet exists. That's what we're speaking of now at layer 2. It's just the technology that you find in most places. So as the layer 3 IP packet descends the protocol stack and arrives at layer 2, it gets encapsulated in a frame. So if you use the word frame, you're speaking of a layer 2 protocol data unit, and you're probably talking about an Ethernet frame. So again, you need to be able to recognize those terms. Let's go one more layer below layer 2. When it gets to below layer 2 to layer 1, the physical layer, we're now talking about bits, binary digits. Okay, the acronym, the word bit is actually an acronym made up of binary digit. The BI is part of the first two letters of binary, and then the T is taken off of the word digit, the T out of digit. So BIT, it actually means binary digit. Binary, the prefix bi means two, bicycle, two wheels, or bidirectional, two directions. Binary, two numbers, 0 or 1. That's binary numbering. That's it, zeros and ones. So we'll talk a lot more about binary, particularly when we get into IP subnetting. And so let's get back over to the whiteboard. And now we have made mention of, as we are descending the protocol stack, let me put some of my lines back in here. We have, at layer 4, we have a segment. We go down. When we get to layer 2, this data unit becomes a packet. When we go down to layer 2, it becomes a frame. And we go down to layer 1, it becomes a bit, which is otherwise known as binary. That's a G. Binary digit, okay? So, got to be able to recognize those terms. Now, we spoke a little bit about the end-to-end state of a session. But I just want to mention for a moment the application here and the application here. The idea of client server, we talk sometimes, in one of our earlier sessions, I mentioned that a server is usually a high-powered computer, and that is true. But it's actually about a service that the server is providing. So really, any computing device can be a server. As you saw on my command line, I was listening on port 139. If you're listening, you are a server. You're serving up a service, okay? So your computer may not be scalable to handle a million connections coming in to that service on port 139, but, to a degree, this can be looked at as a server service. If it's listening on a port, it's providing a service. It could be a peer-to-peer service, or it could be a client-server activity, okay? So I could easily run a web server on my laptop, and then I suddenly become a port 80 HTTP service listening. Thus, I'm listening, excuse me for scribbling, and so I become the server, and any computer in the world that starts up a session, a World Wide Web session, using http:// can access the port 80 service. Then this listening will go to established. Eventually, in a matter of seconds or less, I will have an established session from this IP address from an ephemeral port over here, something in the range of 1024 or 1025, I forget which one it starts at, up to 65535, and it will be to my IP address :80. Okay? Of course, this is all about worldwide routability and the idea that you have end-to-end visibility to my IP address. We're going to get into the concept of global routability of IP addresses and the idea that some are publicly routable and some are private and they're not publicly routable. But for now, we're just going to say that this was a public IP address and anyone in the world could get to it. And so I'm presenting this concept so that you understand that the lines can blur between the whole idea of client and server. Okay? So I hope you understand that. And I just wanted to go through some of these particulars related to the layers of the communications model, the client-server process, the protocol data units as they reside at each layer, and what they're actually known as. All right? This concludes the part 2 of this two-part video of these topics, and I look forward to the next time. Hey, I'm back already. So, hey, I know there was a bit of me going back and forth in my own head about what is an ephemeral port starting number or not. And so I looked it up real quick. I just wanted to get back to you on this. A quick Google search turns up a Wikipedia hit, surprise, surprise, on what an ephemeral port is. It's a short-lived port number used by the IP transport layer. Hey, transport layer, layer 4. We talked about that. And so they're automatically allocated. They're predefined in whatever stack software on that operating system that we're talking about. If we're talking about a smart TV, it might have a different range. Linux might use a different one. Microsoft might use a different one. As you can see, the range down here speaks of different ranges, depending. Like on Linux kernels, the range is this number to this number. Windows, the range can be these numbers. Okay, so exchange, various other default port ranges. But the lower, on the low end, we're seeing 1025 on the low end. Here's another instance of 1025 to 65535. The high end kind of differs, but the lowest possible end on this page is talking about is 1025. Another Wikipedia hit shows a list of TCP UDP port numbers. And so here you go of some well-known ports starting at 0, not much, it's not applicable. Starting at 1, you start to see some of the assignments And these are going to be assigned by the Internet Assigned Numbers Authority, IANA. Internet Assigned Numbers Authority keeps track of all of these port numbers and assigns them to protocols and applications as they are created. All right, and so this goes down to 1023. All right, then there's more registered ports. There's a dynamic list, but there's also some of these are registered with IANA as well. These are assigned by IANA. Okay, and so you can see that some of these other ones are assigned to certain purposes. Cisco IPSLA Service Assurance Agent, you'll find on that port. Sometimes the application is written to make use of UDP or TCP, as you see in this column heading up here. So the list goes on and on. And we get way down to, the list of registered reserved ports, or registered ports, gets down to 49,151. Then we start talking about dynamic, private, or ephemeral ports. Okay, and then there's a list of them here as well. So just wanted to circle back with you on that. You can look up more specifics on it yourself, but some of those ranges differ depending on what we're talking about. All right, hey, this concludes this video. I look forward to the next one.